In this video, we're going to be adding and subtracting rational expressions. So I just like these ones back here. Notice that there's no equal sign because these are expressions. And just like when you add or subtract fractions, you want to make sure you have common denominators. So like this one, these are common. All right, so all I have to do is kind of put those together with that same denominator. And you have to be a little bit careful with this one because there is a subtraction sign. So what I mean by that is that my denominator is going to be the same. It's going to be x plus 5. But on top, this is going to be actually 2 minus. And then I'm going to throw this in parentheses, because if you're going to make a mistake, it's probably going to be with subtraction ones, as you have to distribute your negative into that quantity. So really this is saying 2 minus 3x minus a negative 4 plus 4 all over that x plus 5. And if I simplify the top here, typically we write our biggest exponents first all the way down to our constants. So that's going to be negative 3x plus 6 over x plus 5, right? I can circle that as my answer because there's nothing left to do in that particular problem. In this one though, you'll notice that the denominators are going to be different. One's an x, one's an x squared. In fact, if I think of this x squared as actually being x times x, I think, what could I do to this one to also have it be x squared? Kind of take your more complicated one, if you will, and to the other one, you have to multiply it so it looks just like this x squared. And of course, x times x squared, but I can't just multiply the bottom by x. I have to also multiply the top, because what is anything over itself? It's going to be 1. And when I multiply something by 1, like 5 times 1 is still 5. It doesn't change it. So we're just making it look a little bit different, but really we're not changing this at all. So that's why it's an okay math move to do. We're going to multiply the top here to get x squared. And then x times negative 1 is negative x. On the bottom, x times x is x squared. So now I can put these together. This one stays 2 over x squared. Now I can put those together as they have the same denominator of x squared. On top, I think it's written in that right order. So this is just addition. I can just plop this plus 2 in afterwards and say this is x squared minus x plus 2. Now most teachers are okay with this. If yours wants you to factor out that top even more, you might have to do another step there, but I let my students leave it like this. Let's try 2 more. All right, these next 2 are going to be a little bit more complicated. And if you look at this one over here, again, our denominators are different. However, if I kind of try to look at my more complicated one, if I want to factor this, I could take an x out, and that's going to leave me with x minus 1. And this x minus 1 is actually what the other one has. So in order to get these to be the same, I would need to multiply this one by x. And like we saw said in that first on that first slide or first part of this video, I have to do it over itself, x over x. And now if I were to take this x times x minus 1, that's also x times x minus 1, that's going to be my common denominator. All right, so I can leave this side the same. We're going to have 3x squared minus 14 over x squared minus x. And then this side is going to be, if I think I'm going to have to kind of distribute that in backwards, this is going to be plus 2x squared. And then minus 5x, put that minus sign a little bit lower, over, also, this is going to be just x squared minus x. So now our denominators are the same. All right, again, this is just a plus sign, so when I go to put these things together on the top, I can find my like terms, which I have a 3x squared and a 2x squared. That is 5x squared. I like to cross those out as I go. And then negative 14 and negative 5x, the negative 5x is going to come next. We've talked before on this channel about how to put these in the right order. X squared, x, and then no x, so minus 14. And then I can put these all over the same denominator, which is x squared minus x. Again, I like to leave my answer like that. I don't think there's anything else we can do to factor that one, okay? This one, number 4, is by far the most complicated one that we're going to do in this video because it has some subtraction like we talked about in that first problem we did, as well as, look at both of these denominators. They're completely different. We need to factor these and see if they have any factors in common, and we might have to multiply both sides, the left and the right side of our subtraction sign. So what I mean by that is on the bottom here, I think this denominator is actually going to be x times, let's see, if I make this factor, what multiplies me negative 2 and adds to be 1? Well, 2 and 1 do, and specifically it's going to be a positive 2 and a negative 1. Oops, better put my other x in there, x minus 1. All right, just like on this side, put my minus, what multiplies to be 4 and adds to be negative 5, negative 4 and negative 1 do. So I can say this is x minus 4 and x minus 1. Now, if your a term, if you think a, b, c, or a, b, c, if your a term is not a 1, then that factoring becomes a little bit more complicated. That's another way to kind of increase the difficulty of these problems. But for these two, we can just go ahead and do the easy factoring like this. On the top, this is still going to be x and 4x minus 3. But if I look at the denominators specifically, I see that they share an x minus 1. All right, which means that this one is missing an x plus 2. So I'm going to have to multiply this whole thing by x plus 2 over itself. Again, that's anything over itself is 1, so that's okay to multiply by 1. And this one is missing which one? It's missing the negative, or x minus 4 over x minus 4. All right, so I'm going to have to multiply on both sides. Now, one little trick that I like to do is these denominators, those are all the three same factors now. And so when I go to kind of put those in, I'm not going to write that out for 3 or 4 steps in a row. I'm just going to put some placeholders. All right, and you can maybe even just do one set of parentheses, but I'm going to put 3 there to kind of show you that they're talking about those 3 factors and these 3 factors. On the top, let's do this math. X times x is x squared. Negative 4 times x is negative 4x. Over here, let's see, that's going to be 4x squared. First, outer is going to be 8x. Inner is going to be negative 3x. So 8 minus 3 is 5x. And then negative 3 and 2 is negative 6. Again, those are all over those same factors. Now, just like that first problem we did, I need to almost think of this minus sign as being a negative 1 that I have to distribute in. So be very careful with that. That's probably going to be where you mess up if you do make a mistake. So this side is going to stay the same on top, and then this is going to be minus 4x squared minus 5x plus 6. Okay, that's still all over. Now I can put this over one of those. I'll put my same 3 open parentheses for those factors. All right, and now if I want to write this in order, x squared minus 4x squared, that's negative 3x squared. Cross those out. Negative 4x minus 5x is negative 9x. And then lastly, I'm going to have plus 6. So this one you could take a 3 out if that's helpful, but I don't think it is. And then finally, my 3 factors from up above, those are what those placeholders were. I'm going to have x minus 4 times x plus 2 times x minus 1. And that's what that other one was too, so I can put those over the same denominator just like that. And that is how you add and subtract these rational expressions. All right, hopefully this video helped you out. If it did, maybe we'll see you down the road in a different video.